everyone. Thanks so much for joining me for this week's episode of When I Grew Up. On today's episode, it's my pleasure to welcome my guest, Blair Kim. Hey, Blair, how are you?
I'm doing well, Blair. How are you?
I'm good. So interesting right now. Okay, so you guys, just a little backstory. I actually knew Blair in I guess in high school, I feel like, is when we met and crossed paths. We both grew up in East Cobb, Marietta, Georgia. And Blair is here with me now to tell me about what he does. However, it's been 15 years, right?
Yeah, longer than that, I think.
Yeah, it's been a long time. But my previous guest, footwear designer Monique, is friends with Blair. They went to college together, and she asked me, oh, do you know another person with your name? And I was like, actually, I do. It's just one other person, and you're that person. And she was being her cute self and was like, oh my gosh, it's so crazy. He told me he knows another girl named Blair from Marietta, and I think it's you. And I'm like, yeah, it's me. Before we started recording, Blair was telling me it's going to be so weird, this whole podcast, to just be saying my name.
Yeah, but, I'm if it makes you feel better, I'm having the exact same, this is weird. I'm talking to someone also named me.
Yeah, okay, Blair is a pretty uncommon name to begin with. But then, we have the same first and last name, but you guys, we also have the same middle initial. So, Blair, your middle name is
Edward.
And then my middle name is the phonetic spelling for my Korean name, Unju. So we have had one or two mishaps, I feel like, right, in high school. We were talking about it right before we started recording. You were telling me about the library thing.
Yeah, which happened before I met you. So there were signs as I was growing up that there was someone else who also had my name. The library books was one. I remember I got charged for your overdue library books or something like that.
Oh my God, I'm so sorry.
And then, I remember even prior to that, I think we shared the same pediatrician, possibly. And I remember, or I don't know, I can't remember if it was a pediatrician or dentist or something like that, but there was definitely they had asked me about things that never happened to me. I don't recall, but it was something so bizarre that I was just like, no, I've definitely never happened to me.
Right. No, it would be weird because it's they're like, well, is your name Blair Kim? And yes. And then is it Blair E. Kim? Yes.
Right. Exactly. Exactly. So, and usually nobody dives further than that.
Right. And we're the same, we're born in the same year, 1988 too. So it's not that's really crazy. And then, so now as we're talking, I do recall going to the library and them asking me about something. But then I said, oh, that's not me. And they're like, yes, it is. And I'm like, no. And then they asked me what my home address was. This is very clear to me, actually. They asked me my home address, and I told them, and they're like, oh, this is not you. And I'm like, but how could it not be me, is what I thought.
Right, because Blair in itself is a relatively rare name, right? I don't know too many Blairs. Much less those that share the same last name and middle initial.
So weird. I was also telling Blair that because you went to a magnet school.
Mm-hmm.
And which is for smart people. And then I remember thinking, oh, it would did you live in Wheeler District or you went to that school?
No, I lived closer to you. I lived in Sprayberry.
Oh, Sprayberry District. Okay.
Yeah,
so, if we had gone to the same high school. I remember thinking at some point, because I knew that you were smart, and so so I was like, man, if our transcripts got like mixed up, like it would be okay for me, but not for you. But anyways, all that to say, Blair, thank you so much for joining me tonight. And without further, I'm sure we could joke about our names all night, or at least I could. But yes, why are you here? You're here to tell me about your job. So without more of just conversing about this, what is it that you do, Blair?
I am a staff manufacturing engineer at Tesla. That means a lot of different things.
Yeah, I'm like, what is that? The only thing I understood, if I'm honest, is Tesla.
Yeah. So Tesla, I think, needs no introduction, but really briefly, we make some of the best performing electric cars, as well as well-known charging infrastructure, solar panels and solar roofs for your house, and then battery packs for residential and commercial purposes. Yeah, and but yeah, the cars are definitely the thing we're known for, right? Yeah.
So what does you said staff manufacturing engineer?
Mm-hmm.
What is it that you do in particular?
I lead a small team of other manufacturing engineers. In terms of what we do, that has a lot of different answers. We wear a lot of different hats. So depending on what phase of a particular program we're in, we could be leading construction for new buildings to ensure that the building is built to our specification to meet the needs of our manufacturing lines.
Okay.
We could be like floor integration or commissioning team leaders, meaning we're working with other companies to bring up our equipment, to ramp it up and make sure that it's performing and building the number of cars that we want, and having good yield, cycle time, and availability, which means that the line is just really pumping out cars as fast as possible, and that it's not breaking down, it's not producing bad product, anything like that. We might be designing, like working with design engineers to provide what we call DFM feedback, or design for manufacturability feedback, making sure that our design team may be designing some amazing car, but if we can't build it, then it doesn't matter, how amazing the design is if it's not what we call like able to be manufactured. Or like we might be improving existing lines, or existing manufacturing lines to make them produce more cars faster. We can be doing lots of different things. So there's no typical day or typical even season, especially because Tesla is growing so quickly. What we were doing 2 years ago versus what we were doing 4 years ago versus what we were doing 10 years ago is like vastly different, right? So
I see.
Yeah.
I would imagine it is a fast-paced kind of environment for you guys over there. So I'm not even going to pretend I fully know everything you just said, because I'm just ignorant in that way. But in just like the technical terms. But something that you kind of mentioned previously when you and I were initially talking about you coming on the podcast was you said that you listened to my husband's podcast. But like, what you said was because it's similar, but it's not, right? Like, so my husband's a structural engineer, but you said that it's similar, but it's not the same thing, right?
No, it's very different. So he's obviously working more with structures.
Yes, yes.
I deal with structures on a much smaller level that are, um, yeah, like for example, one. Well, I can't. I guess I can't use examples,
Oh, yeah,
but
don't use examples, man. You're gonna get in
uh,
trouble.
yeah. But we also have to build structures and make sure that they're safe. But they're structures that are used for manufacturing rather than for people to reside in or to work in.
I see. So to manufacture whatever product that you're making is what
Hmm.
you're structurally building.
Yeah, that's a small part of our job,
Okay.
but yeah.
Sorry, I'm just trying to understand.
Yeah, it's okay.
Okay. So um you said so you're managing another team of engineers that do all these things because you're the staff manufacturing engineer. What are you saying?
Um, I'm a staff manufacturing engineer, but I'm also a leader of a team based here in Texas.
Okay, okay.
There are currently 5 engineers that report to me, but we are looking to uh, between double and triple our team in the next year.
Oh
So
wow. Awesome.
yeah,
Um uh so in college, what did you study?
I studied mechanical engineering at Georgia Tech.
Okay. So a lot of Monique was mechanical engineer, right?
That's right. That's where I
Yes,
met her.
yes. Okay. Okay. So when you left high school and you left Wheeler, did you know like this is what I want to do? I want to be a mechanical engineer.
Mm, no. Honestly, I don't remember the thought process behind why I chose mechanical engineering.
Mm-hmm.
Um, and honestly, I wasn't even sure I would be good at it
Mm.
until I got to my first job and then
Which was what?
started. I worked at Bridgestone, the tire company,
Okay.
designing high speed automation to make tires. And
What? For real?
yeah, yeah. And as soon as I got into that, I realized that it's something I really excel at and
Hmm.
that I have sort of a natural engineering intuition. And so after that first job, my path became much, much more clear.
Okay, so I have to ask, what you said sounded really cool. But can you go into the details of what that is?
Uh,
Uh,
automation, like designing automation.
yes. Like a
Yeah.
car? You designed a car? A
No, no,
tire?
no, no. Just machines that make products. So that's what I've been doing for my entire career is I design, integrate, work like install equipment
Uh-huh.
that uh, manufactures products. So my first
So
job
like
was
oh, I'm sorry.
making
I'm sorry. Go
machines
ahead.
that make tires.
Uh-huh. Okay.
So the cycle time was roughly a minute to 2 minutes. So each machine had to produce a tire every minute. Um, and it's not just a single machine that does it, but there's a series of machines um, that make each component of the tire, and then it's all assembled together at the end, and then it's vulcanized or cured. Um, and that's the typical process of like making a tire. But I've always like the tools that you use in your toolbox to do any kind of manufacturing is really the same tools. So
Hmm.
how do I get parts from position A to position B, and I need to flip it over and inspect it along the way or something like that.
Hmm.
We use like engineers who work with automation, high volume uh, automation, have to use the same sort of tools in their toolbox. Yeah, and I've just like that's what kind of gave me um, indication that I knew I'd be good to work at Tesla as well because it's just something I excelled at no matter where I worked at.
Okay, so what you just said gives me a I feel like so something like that, an example you gave when you were working at Bridgestone,
Hmm.
is that kind of what you do at Tesla right now? Because that gave me a
Yeah, it's
little
very
better
similar.
picture.
It's very similar. So the car is not made on a single machine like
Uh-huh.
statically, right?
Uh-huh.
A series of parts, are assembled along the way,
Uh-huh. Uh-huh.
um, and uh, yeah, and the car moves along, and parts are constantly added to that vehicle, right? So my group is responsible for part of the powertrain or the drivetrain of the vehicle. So um, I initially started at Tesla working on the battery side,
Uh-huh.
um, and then I now am responsible for the motor, um, or motor manufacturing at Texas.
Wow, that's really cool. So, you found your kind of your niche when you were at your first job at Bridgestone. Like, how did you get that job? Was that provided through something at Tech, or you just,
I got very lucky,
okay?
uh, but yeah, I to make a long story short, I didn't excel in college nearly as much as probably you think. I had actually very low GPA,
What?
but because and I did like numerous interviews until I got that first job, and I guess one of my takeaways from that whole experience is that um, schooling is just the first step in a long series of steps
Mm-hmm.
to get to where I am today.
Mm-hmm.
Um, like I, it's very important to have that schooling to understand how to get answers,
Mm.
and to get your foot in the right doors. But the vast majority of what I've learned today has been on the job
Sure, yeah.
from my work. Um, so if you ask me, like, do I remember things from school? I probably remember less than 1%. But what I do remember is how to get the answers. Um, so do I remember the formulas? No, definitely not. But I remember the resources that I needed to get the answers, and then I remember like the um, I guess the critical thinking to apply those resources to find out what answers are,
Yeah,
if that makes any
absolutely.
sense.
No, yeah, it makes perfect sense. I mean, I think even my husband and I, we talk about it all the time. As an engineer himself, he doesn't remember anything from
Right.
school.
Exactly. Yeah.
But he says like, oh man, like if I had like the opportunity to work as a structural engineer before going to school,
Hmm.
school would have been different. Like
Right.
the
Yeah.
way
I heard him
he,
say that.
yeah,
That's so true. Right. Like what I would have paid attention to and what I would have like valued at school would be very different.
right.
Um, but yeah, so I didn't have a good GPA, but I got that job because I think I demonstrated that I knew what I was talking about,
Hmm.
through an interview. And I think the recruiter or not the recruiter, but the hiring manager for that position was very similar to how I am today, in that like he was like, I don't care about your GPA if you can demonstrate that you know what you're talking about, and like you have some critical thinking skills, you're articulate, you can yeah, find the answers even if you don't know the answers.
Hmm.
That's what's far more important than how well did you do in your finals, or uh, yeah, what's your standardized test scores, those kinds
Yeah,
of
no,
things.
I completely agree. So this job, was it while you were still in school or you just gotten out of school?
I got it, yeah, while I was still in school.
Okay. So it was there that you decided that you're going to go mechanical engineer?
Um, yeah, I guess so. Yeah.
Okay. So, you said you felt like you had kind of a natural inclination towards like engineering and this type of engineering. Can I ask you like what kinds of things came easily for you that you realized, oh, this is something I want to do? I don't know if you can pinpoint it,
Um,
but
so my dad likes to brag that I was engineered to be an engineer. And I don't know if that's true. Um, but his evidence is that he provided me with infinite Legos when I was growing up. We had a lot of books about how things worked and what they looked like on the inside, like cutaway
mm,
books. Um, I had a lot of like sciency engineering type toys where you like build things. Yeah, Legos is a perfect example. That's the big one that I can think of. But like Connects um, and he claimed I was always like taking apart his power tools and then not putting them back together, things like that. Which I don't recall, but uh, yeah. So yeah, like as soon as I sort of went down this career path, my dad was like, "You were engineered to be an engineer," and
mm,
I'm like, and yeah, when I design equipment, like there are a lot of things that come naturally to me. Like thinking about how something's made and how structural it is, what it looks like in 3D space, like that all comes, yeah, very naturally when I'm
oh,
designing high volume manufacturing equipment.
interesting. So, um, you're actually designing the equipment itself?
Yeah, we do. So my team is relatively small. So we do some small pieces of equipment, but quite often we'll engage what we call integrators or machine builders who are outside engineering companies who will do the heavy lifting for us. So we will define a process, we'll write a specification um, to, for example, make a product. So, for example, um, yeah, I guess making the car. Well, like at a very high level, equipment specification would be like the car needs four wheels. It has to be aerodynamic. It has to have this kind of efficiency. And then within that specification, there are freedoms. So, like, do I care about how the wheels, whether the wheels roll to the car and get installed onto the car, or do I care about like, or do they have to be like flat, or do they have to come down from the ceiling? Like, I don't
Mm.
care what that is, but I will just say once the wheel is installed in the car, the bolts need to be tightened, the seats need to be installed, the steering wheel needs to be installed, and I can define those things, and then the integrator or the machine builder has certain freedoms to use what's in their toolbox and what they're good at to um, do some of the finer detail design work.
I see. Wow,
Um,
that is so neat.
yeah. We build a lot of manufacturing lines, what we call 'em, or assembly
Okay.
lines,
Yes, yes.
where specific products get assembled. So
Mm.
whether that's your steering wheel or seat or wheel or battery or motor or the shell body of the car, like there's all kinds of manufacturing lines.
Mhm, mhm.
Um, and we write these specifications. Uh, we write like capex documents. Capex stands for capital expansion. How much money are we
I
like
see.
asking to spend out of Tesla's piggy bank to like do this? We justify our spend. um, we go to uh, what we call factory acceptance testing, like making sure that once the equipment's designed and built, that it actually does we've asked for it to do. So, yeah, it's similar testing as like the vehicle, right? So the vehicle has to go through a number of different validation steps to make sure that it's safe, that it's fast enough, that it's efficient enough to like meet the customer's demands, right? Well,
Right.
in this case, we're the customer. We want our machine builder to like meet our demands, and
Sure.
so we'll work with them to, um, yeah, to help them as much as possible so that we get the best possible outcome out of the assembly line.
Man, I never even thought about this job ever. It's very cool. Blair, can I ask you, you mentioned a few times, like just about critical thinking, problem solving, and I understand that that's what engineers do, right? They problem solve
Mm-hmm.
and they fix problems. But is there like an example that you can give me? It doesn't have to be about Tesla's situation or anything, but of like where you as someone that designs those kinds of things like would have to problem solve, maybe like even when you receive the product as a customer, like is there situations, like I don't know, I'm just making assumptions obviously, but like I don't know, it's not what you thought it was going to be and you have to figure out what to do with the amount of money you have, or I don't know, what do these problems look like?
Ooh. Uh,
Maybe a
hmm.
general problem, not like
I
a
know.
specific.
I'm trying to think of a super general one. Um, do you own your home, Blair?
Do I own my home?
Yeah.
Yes, I
Have you?
do.
Yeah. So when you bought your home, you from the either the builder or the previous owners, you had an inspection done for the home,
Yes.
or an appraisal of the
Yes.
property, and you had, uh, yeah, like in a very similar vein, like I do those kinds of things
I
with
see.
manufacturing equipment. So
Okay.
I will inspect it to make sure that it does have four walls, a roof. The foundation is not sinking, and it actually does. It's like safe to be in. Using a house as an analogy, that's
Yes.
yeah. I don't know. That's probably not a great one. I'm
No,
trying to think
no.
of
I
others.
get it. I get where you're going.
Yeah.
Okay, so you yourself do the inspections when the product comes in then.
Are we still talking about Tesla, or are we talking
Yes, we're
about
talking about
engineering in general?
Tesla.
Yeah, yeah. Then yeah, I like myself and my team. We will travel to the various acceptance tests, as
Uh-huh.
we call them,
Uh-huh.
to like make go through a checklist that we make that says, does this equipment do everything we asked for it to do? And does it do it fast enough? Does it do it safely enough,
Uh-huh.
such that like people can work on it
Uh-huh.
without getting hurt? And can we actually make money from this equipment?
So if something were not to be to your standards, you would just what, like send it back or
So usually, typically, we travel to their sites
I
first
see.
where
I
they've
see.
built the
Okay.
equipment, and then
Of course. Yes.
yeah, like it's much easier to travel there than
Yes.
ship the entire assembly line.
Sure. Mhm.
And yeah, and if it's not up to standards, we'll say it's not ready, and you have to keep working on it. Um, Tesla, unfortunately, though, some we have deadlines to meet, and so sometimes we have to make hard decisions where we have to make certain concessions that,
Mm,
given if we had all the time in the world, we wouldn't do.
sure. Yeah, yeah, yeah.
But yeah, Tesla is all about speed, right? That's I think everybody can make um, the product that we do, or the product like electric cars. Obviously, the other OEMs or original equipment manufacturers are getting into it. Um, you can buy electric cars from Ford and GM and Mercedes and BMW like nowadays. Um, But the thing that makes Tesla different is like the speed uh, at which we do our complete our programs, the speed at which we build our factories, um, and the car itself is like incredibly fast. I don't know if you've heard about our latest car. It's very fast.
No, I'm sorry, I don't
It's okay.
really pay attention, but I should. But but how fast is it? Can you tell me about the car?
Yeah, it's called the Plaid car.
Uh-huh.
So if you know Tesla, a lot of our references are uh, from the movie Spaceballs.
Yeah,
Um,
actually I did know this. I don't know
yeah,
who told me this,
so
but
the car a few years ago we had Insane Mode, which was a very very fast car. Then we came out with a faster uh, version of it, and it had Ludicrous Mode.
oh. Mhm.
And then the only thing beyond ludicrous is plaid, and that comes from a reference in Spaceballs where I think they're going through warp speed, going from insane to ludicrous to plaid mode.
Plaid.
And plaid is this ultimate car that we make today. My team has helped work on it,
Mm.
and it's the car is worth you like searching on YouTube to see what it can do.
I will have to
Um,
definitely do that.
but it's the fastest car uh, on the market today, like hands
Really?
down. Yeah,
Is is it
outside of like $1.5 million supercars.
Oh my gosh, that's crazy. So this is a car that like how fast does it go?
It does 0 to 60 in under 2 seconds.
What?
Yeah,
That's freaking fast, man. Okay, I'm gonna go look it up after this interview. But uh but so
it accelerates faster than you can fall. That's how
yeah,
fast it.
that's ridiculous. That's
Yeah.
ridiculous. Well, I mean, guys, if you haven't realized yet, there are certain things that obviously um Blair cannot disclose because of his work and where he works, and which I totally respect. So thank you again for just kind of doing the best you can. This interview is not over. I just wanted to just make a point that that's why we're kind of being careful, and I want to totally respect you and what it is that you do. Um, so I have to ask, and I'm sure a lot of people are wondering, a lot of young people are wondering that are listening, is like, yeah, what is the journey to working at Tesla? You know, like how did you get where you are today? Be
I
specific, man. Like I want the whole story, like
yeah
all the
I
details.
I was recruited.
You were
Um,
recruited.
yeah, someone found me on LinkedIn, um, based on my current or at the time my current career path, which I had done high volume manufacturing of tires, and then I switched to another company called Certis Simmons, making beds,
Hmm.
and I was the coiling engineer. So I was
Oh,
responsible for.
Serta, like Serta the
Yeah,
mattress.
yeah,
Okay, okay.
that's right, and I was responsible for making the bed spring and making
Oh.
like thousands of those in a single minute. Um, and so the equipment I worked on had to like make all these like little springs as fat. Not they weren't that little. They're about that size. Um, you know, very very quickly. And
Mm.
I was recruited to be for a different role. I interviewed for that role. I completely bombed the interview. I knew nothing about what I was talking about, and Tesla uh, thankfully did not hire me for that role. They filed me away, um, and then when for my current role, or actually when I first started at Tesla, my role, um, the recruiter who was responsible for searching for that position found me in like I guess the people that had been rejected, and like I interviewed for this current role and, rock that interview. And that's how I got where I am today.
Oh, wow. And how long ago was that?
About 5 years ago.
Oh, okay. So you've been there for a good
5 years.
chunk of time now.
Yeah. I'm a veteran Tesla now.
Yeah.
Because the company's not been around that long, so there's not that many people who have been here as long as I have.
That's true. I don't know why that didn't occur to me just now. But so like were you excited? Like when you got the job? I'm just curious.
Oh,
like,
yeah. I was ecstatic. Yeah. I don't recall this, but one of my friends said that in college I had said it was my dream job to work at Tesla.
Really?
But I honestly don't recall ever saying that. But yeah, he was like, in college you used to say that your dream job was to work at Tesla. I was like, really? I really don't remember that, but it's lucky that happened.
Yeah, no, it's not lucky. You put the work in and you did it, man. It's awesome. Okay, yeah. So I have to ask now, like, what do you enjoy most about your job specifically? Not like working at Tesla, like your job.
No 2 days are the same.
Oh.
I'm never doing anything monotonous. It's very, very difficult to get bored. Yeah, and I actually, you know what? I really do believe in Tesla's mission, which is, getting the world to transition to this sustainable electric car, electric energy. There is this underlying, in my mind, like sense of urgency, especially given like all the, natural climate disasters and like evidence of climate change caused by, human behavior, like that. It's very rewarding knowing that every car that I help make is one gasoline car or fossil fuel burning car off the road. So yeah, that's what I really enjoy as well. Like just knowing that what I do is having some very major tangible impact on the world we live in today.
Yeah, for sure. Now, what do you like least about your job?
What I love the most and what I love the least are kind of the same thing.
Okay.
It's the speed at which we move. So as a byproduct of that speed, sometimes we don't have time to give things the attention they deserve. And we have to deal with a lot more unknowns in our programs than I've ever had to deal with in previous positions or previous careers. Yeah, that's quite difficult. Yeah, I think that sums it up.
That's good. So, I'm wondering if there's somebody that's listening to this particular episode and is like, man, that's pretty cool. Like I want to do stuff like that. I want to be able to design equipment that does things like that, whether it's for Tesla or somebody else. Do you have any advice or just some wisdom of like what they could be doing now as maybe a person in college or even before entering college that you feel like would be helpful in making them a better engineer? I don't know if my question makes any sense. Do you have any advice, Blair? Do you have any advice?
I would say study the world around you. Look at the things that you interface with every day, whether it's your phone or your computer or your car or your computer mouse. Um, and think about if you had to make a lot of those quickly, how would you do it? Like what kind of um, like I think the phone is a good example, right? Like Apple pumps out a lot of iPhones and a lot of iPads and a lot of laptops.
Yeah.
Um, and uh, there's tremendous demand for that product. So they have to make a lot of those really quickly. So how would you do it such that um, you're not having a guy sitting in front of like a mill or a lathe, like making this by hand? How would you automate that so that um, you can walk away from your machine, just like your rice cooker, right? Like you get it, you fill it with rice, you prep it, and you press go, and then you walk away. And when you come back, the rice is done.
Yes.
That's a good example of like how automation has changed your life, right? So,
Mm.
um, like if so, your rice cooker literally manufactures rice for you or cooked rice for you. Um, yeah, like how would you do that at a higher volume for everyday objects in your world? That's what I would suggest. So think about like look at your um, I want to use the word toolbox, but I know that the things I have in my toolbox are very different from the things that
No,
people
it's
have
very
in.
different than most people, Blair, I would
Yeah,
imagine.
but yeah, like between electric motors and pneumatic cylinders and hydraulics, like there's a number of different ways to uh, perform processes and move parts around.
Mm-hmm.
Um, and yeah, and yeah, the high volume manufacturing makes use of all those tools from
Yeah.
robotics to something as simple as like a two position pneumatic
Right.
cylinder that just goes back and forth, right? Um, so yeah, like look at the world around you. Think about how could the things that you interact with every day um, be made if you had to give one of them to every single person in the whole world.
Wow. I mean, I just like for me, my brain just like mind blown because I don't think about that at all. At all.
Mm-hmm.
And it's like, yeah, I mean, if you start training your mind early to start thinking about it and then I mean, so all those tools that you mentioned in your toolbox just now, like is that
Mm-hmm.
something that you learn in college? Like do they give you those tools like
No, yeah, college maybe gives you a very, very like shallow introduction to those things,
okay,
and
okay.
then it's really like being hands-on, um, where you like learn how to use those tools.
Amazing.
Um, yeah, and the same goes for my team too. Like we can design stuff behind a computer all day,
Mhm.
but then it's not until you like go down and like sit with the equipment and um, like troubleshoot like why certain automation components aren't doing what they're designed or intended to do,
Mhm. Mhm.
that you really start to understand how the whole thing functions as a system.
Yeah, yeah.
Yeah,
Do you get really like a lot of satisfaction from like seeing the design come to life?
I do.
I mean, I would.
I get
Yeah.
tremendous satisfaction.
I mean, especially if it's
Um,
working the way it's supposed to and the speed that you want it.
yeah, yeah. You're for some of my designs that I've uh, designed, built, installed, and like integrated into assembly lines that are still functioning today. Like I am very proud of those.
Mm.
They're, I guess, hallmarks of my engineering prowess, I would
Of
say.
course. Yeah, that's
Um,
awesome.
yeah, and yeah, it's like it's really cool knowing that, like, for example, every, I don't know, battery or every motor that like is made by Tesla has to like has some process done to it, or um yeah, maybe something's added to that product by equipment that I designed and made and like installed with a team.
Yeah, I mean, I'm
Yeah.
definitely never going to look at a Tesla ever the same again, Blair. Knowing the impact that has probably um been produced from something you and your team has done. So it's I mean, I personally think it's really cool. And was there anything else that maybe I didn't ask you about that you wanted to kind of share about your career or your job?
Um I do want to say that I am super blessed in that everything that I have done, and including every what I thought were career mistakes at the
Mm.
time, um, has brought me to where I am today. Like, I cannot
Mm.
imagine doing anything differently and still ending up in the same place.
Yeah.
Um, and everything I have done has been in some way or another valuable. Um, I don't feel like I've ever um, wasted time,
Mm.
uh, like working somewhere I hated, because there were definitely, you know, uh, parts of my career that I hated,
Mm.
but I'm very fortunate to have them because they got me to where I am today, and I
Yeah.
really love where I am today.
Just just to make things a little real, like are you willing to talk about some of those more harder and difficult times of your career?
Um, yeah, sure. I can talk about something at Tesla actually. So in 2017, 2018, Tesla was going through what we call today production hell, which was
Sounds terrible. What is that?
yeah,
Oh
it
God.
was it was where we were trying to do we were trying to launch the Model 3 vehicle, which is our high volume, uh, relatively inexpensive
I was gonna say, I
sedan.
isn't that the like the affordable one,
Right, that's the affordable
like the
one.
30,000 something?
It's more than that, but yeah.
Okay, well, okay, like I remember a base model coming out and everyone was like on a waiting list for it.
Right, right. And the
Okay.
reason they were on a waiting list is because we could not manufacture them fast enough. And in fact, we couldn't manufacture them at high volume at all. We were only manufacturing them at low volume. And our executive leadership got involved.
Hmm.
Um, and uh, yeah, I spent a lot of nights, uh, and my larger team as a whole did as well, working to get this equipment running and performing.
Hmm.
And yeah, it was quite a struggle. It was definitely the hardest, like, trying time of my life. There were, yeah, some very, very long, I don't even want to say days, they were long months, where I slept at the factory, like right by the equipment. Um,
Oh my
I,
gosh.
I think there were times where I would like go home, sleep for like 3 hours, and then go back to work. Um, and uh, yeah, it was a rough time, but yeah, like that experience taught me so much.
Hmm.
Um, Number one, just because I'm living with the equipment, there's like you have a lot, you make mistakes a lot faster, you iterate faster, and you learn faster.
Mm-hmm,
Um,
mm-hmm.
so as difficult as it was, yeah, I wouldn't trade it for an easier experience.
Yeah, absolutely. I mean, okay, so I understand that it was a difficult and challenging time because there were the leadership wanted to see results and it wasn't happening. And
Hmm.
it affected you and your team. I'm Are you allowed to kind of explain like oh, like, so for me, it's like, oh, like, why weren't you sleeping? Like, why were you staying awake? Were you trying to figure out solutions? Is that
Yeah, we
why?
were trying to solve problems with the automation that
I
were
see. Like, to
um,
make it faster?
to make it faster and to make it produce higher quality parts.
Ah, okay, okay.
Um, like if
I'm so stressed even
we
thinking
have
about it.
we have a standard, right?
Yeah, of
So
course. Uh-huh.
things that don't meet that standard are either yeah, like defect defect product or low quality, and like we can't like uh you can't always rework it.
Mm,
So you may be throwing away uh, parts, like you're losing entire vehicles because
right.
they're substandard, and they're unsafe or something like that. So
Mm,
we were working really hard to improve the yield and yeah, and cycle time and availability. Those are the sort of three um, things that uh, feed into the output of what the manufacturing line does.
gotcha.
So yeah, and one thing I really like about Tesla is Tesla pulled out all the stops. Like this this manufacturing line was particularly problematic, and Tesla pulled resources, meaning they pulled other engineers from other areas, said, "Stop what you're working on. You're going to go help Blair." And at like there were probably yeah, I think over 100 engineers working to solve problems on this one line, and then like literally hundreds of other like technicians and um, construction workers and operators from who were like just pulled out of the woodwork to like being told like stop what you're doing, like I know your job description is this, but today you're going to go do this.
Wow.
And yeah, like Tesla very quickly shifted the resources to like help solve really really challenging problems, and I am proud to say I like worked with the very best of the best engineers at
Yeah.
Tesla, and through that I developed a lot of relationships and connections, um, and some of those engineers are still around today who still help me and I help them,
Mm.
and um, yeah, sort of networking within the company, if you will.
So production hell was worth it because you grew from it.
I grew personally, um, and the people that have gone through it and survived are, yeah, some of the best engineers I know today.
Amazing. That's awesome. Well, thank you so much for sharing like so transparently about that cuz I feel like, for me it's like, yeah, like you work at Tesla, it's awesome, but I know with any job it comes with its challenges, and I think,
Hmm.
hearing some of those things is not always like, glamorous. As maybe one might think is really sobering to hear, and people need to know, that
Yeah,
it's work. It's work.
yeah, yeah. I
um,
think most people don't realize all the things that are involved with manufacturing a car and hundreds, if not thousands, of engineers and technicians and machine operators, and how many like tens of thousands of processes that happen to that vehicle until it's like, arrives to your door. Like, it's a symphony of complex problems to solve, to make that automobile and to get it to your door, all the way from like design and supply chain to machine operations, to manufacturing engineering like I do today. I get to work with a lot of cross-functional teams. Cross-functional meaning like they do other purpose, or they serve other roles within the company, but we work together. And like, even though I mentioned before, I work with some of the best engineers in the world, I think, but I also get to work with some of the best technicians in the world, and some of the best operational leaders, and some of the best leadership in the world. And that's really a privilege.
No, absolutely. And I just find it all so fascinating, everything you said today. And I truly do have a new appreciation for not just a Tesla car, but it sounds like just any car in general, like that I see it, that I drive. And thank you again, Blair, for just like telling me about what you do. It's all been really great. I always ask people, my guests, if there's anybody listening that maybe has like questions about your job, or just like that type of work, would you be open to connecting with them?
Absolutely. Yeah. They can just look me up by looking up your name.
Yeah.
I'm just kidding. We have the same name. So it should be really easy to remember. You can find me on LinkedIn, or you can just reach out to Blair, and I'm sure she'll give you my contact information.
Awesome. Thanks so much again, Blair. Guys, if you enjoyed this episode, if you have questions for Blair, not me, Blair, but him, Blair, please feel free to reach out. Like he said, you can DM me, or you can email me at podcastwigu@gmail.com. Thanks, guys. Thanks again, Blair, for everything.
Yeah, my pleasure. Thanks.
Until next time. Bye.